Hi there, welcome to edupediaworld.com. You're watching the videos on areas of parallelograms and triangles. So in this video we'll discuss some of the more advanced questions which are related to parallelogram. So how we can use to concept of congruency and area of parallelograms to compare the area of parallelograms and triangles, so which are very important from the exam point of view. So let's discuss the first question, question number 1. Now the question says that in figure AP is parallel to BQ, so this line is parallel to this line and BQ is parallel to CR. So we need to prove that area of AQC, so this one area, this one big one area, equals to area of P, B and R. So let's see how we can prove this. Now if you consider trapezium, so why this is trapezium? Because one pair of sides are parallel only, they are not equal. So if you consider trapezium APQB, right? So in this trapezium, area of B, or we can say ABQ, is equals to area of PBQ, right? So why they are equal? Because they share the same base BQ and they are between the same parallel lines AP and BQ. So they have same base BQ and same parallel lines AP is parallel to BQ, right? So let's say this is the first equation. Now if you again consider trapezium BQRC, in this trapezium again area of BQC is equals to area of BQR, means this area of BQC is again equals to area of BQR. So why they are same? Again they have a same base BQ and same parallel lines BQ is parallel to CR, right? So let's say this is our first equation. Now what we can do is we can add these two equations. So we can say that adding 1 and 2, what we get is area of ABQ plus area of BQC equals to area of PBQ plus area of BQR, right? Now area of ABQ means this area plus area of BQC, so this area, so it will come out to be area of QC, AQC. So we can write, so this area plus this area is area of AQC, which is equals to area of PBQ plus area of BQR will be equals to area of PBR. So it will be equals to area of PBR, right? So this is how we can prove these type of questions. So let's discuss the question number 2 of this video. Now the question says that diagonal AC and BD of quadrilateral intersect at O. So let's say first we need to draw a quadrilateral ABCD. So let's say we have a quadrilateral ABCD like this, ABCD, and the diagonals AC and BD intersect at O in such a way that area of AOD equals to area of BOC. So it's given. So first we need to write given area of AOD equals to area of BOC, right? Now so we need to prove that ABCD is trapezium. So let's say how we can prove this. Now since these two areas are equal given, now if we can add, so let's say first we need to write area of AOD equals to area of BOC. So it's given. Now if we add the area of AOB to both sides, let's say what we get. Let's say we write add area of AOB on both sides. So what we get, area of AOD plus area of AOB, which is equals to area of BOC plus area of AOB, right? Now area of AOD plus area of AOB, it will become area of ABD, right? Then again area of BOC plus area of AOB, it will become area of ABC. Now you can see properly, area of, this means area of ABD is equals to area of ABC now, right? So if these two areas are equal and they are sharing the same base, so this means the line CD and AB should be parallel. So we can say that the line CD should be parallel to AB. So why the line should be parallel? Because since area of ABD is equals to area of ABC and they have a same base AB, so we can say by converse of the theorem, so CD is parallel to AB. Now if in a quadrilateral one pair of sides are parallel, so it's a trapezium, so then we can say that ABCD is a trapezium. So why it's a trapezium now? Since CD is parallel to AB. So we have proved this. So this is how we can prove these type of questions. So let's move on to the next question, question number 3, so which is the last question of this video. Now in this question it's given that area of DRC, so let's say this is the area DRC, and area of DPC, so this is the area DPC are equal, and it's also given that area of BDP means, let me use another pen now. So this is given, area of BDP is equals to area of ARC, right? Now so we need to prove that ABCD and DCP are trapezium. So first we need to write given. So it's given area of DRC is equals to area of DPC and area of BDP is equals to area of ARC. Now since you can see, check that it's given area of DRC equals to area of DPC. Now DRC and DPC, if you can see properly, they share the same base. They share the same base DC, and now if the areas are equal and they share the same base, so this implies is CD should be parallel to RP. So why? Because both the area of DRC is equals to area of DPC and they have a same base DC. So we can say by converse of theorem, again converse of theorem, so these two lines are parallel. Now we can say that DCRP is a trapezium. So why it's a trapezium now? Because since one pair of sides are parallel, so it's a trapezium now. So this is how we can prove this type of question. Now let's say we need to prove now ABCD is a trapezium. So let's see how we can do this. Now again it's given that area of BDP is equals to area of ARC. Now area of BDP, so means this one area, right? So this complete area, right? Now we can split this area, so we can write this as area of BDC plus the area of DCP or area of DPC. Similarly we can write this area of ARC and we can split the area again into area of ADC and RPC. So we can write this as area of ADC plus area of RDC, right? Now, since we know that these two areas are equal, so we can cancel them out, right? So what we are left with now, area of BDC is equals to area of ADC. Again, these two areas are equal, so area of BDC and area of ADC, again they share the same base DC, so again we can say that they share same base DC and they are between the now if they share the same base and the areas are equal, so this means that what AB should be parallel to DC, so we can say that, then we can write AB should be parallel to CD. So why? Again because the areas are equal, or we can say that by converse of theorem, right? So again we can say that ABCD is a trapezium. So why it's a trapezium now? Since AB is parallel to CD. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day ahead.